Good morning, students. And today we'll be working on the first case study of Huggingface, which is name entity recognition. And I would like to say that this case study is not limited to actually name entity recognition. It should be able to generalize to also things like part of speech tagging. Yeah, basically anything that is like you want to classify each of the token, right? Whether what entity or what part of speech or whatever, right? So those tasks commonly is actually called token classification, right? And what we're gonna do basically today is something like this, right? In which, for example, like Chucky is flying at AIT. What we want it to do is actually perhaps classify this as person. This is nothing. This could be nothing, and this could be nothing, and this could is a location, right? So this is the idea of token classification. I would say subtask of token classification. So yep. So this is exactly what we plan to achieve. And to do this, we have to find some existing data sets that allow us to actually teach the model what is a person like and what is a location like, right? So that is like the basic idea of what we're gonna do today. Similar to as usual, let's take a look what we're gonna do today. We'll be first loading data and do some pre-processing. I would say that in terms of using Hugging Face, the most typical part usually is the pre-processing, in which you have to know for certain tasks what is the right way to pre-process the data, right? To be in the right format so that it can be input to the model in the correct manner, right? Data loader, we're going to prepare them in batch, send to the model, and defining the model. This is just a couple liners. Matrix, we're going to introduce something called eval, in which is basically by Hugging Face, and it automatically calculates everything for us, just like classification report of sklearn. I also have written some code to make sure that this video doesn't go more than 1 hour. So optimizer, for example, is very simple. So I just show you guys the code. Accelerator is basically something like you don't have to write your own training code. Everything is here. It's by Hugging Face, a very nice code, and we're going to talk very quickly about this. And learning rate scheduler, basically setting how we update the learning rate. Very simple to write. And we also going to talk about how we're going to push our model to Hugging Face, right? And then we can start training, right? Which I also, you can see that the code looks very similar, except that we now are using accelerator. And then finally, we're going to do some inference, in which, for example, I enter something like Ayush and Chaklam are going to play soccer today at AIT. Then it can identify that Chaklam is actually a person, right? So this is exactly our end goal. But without further ado, let us start working. So today, I mean, to train name entity recognition, you have to have data sets, right? And here we're going to use this data set called NER 2003 data set. So let's start loading this, right? So we're going to say from data set, import load data set, raw data sets, load data set. Right. So that is okay. So I cannot find that, and probably I miss a S. Okay. So hopefully this does not take too long. Okay, great. And then I think we can take a look at data sets a little bit. And so obviously there's a train, validation, and tests, and each of them seems like there's our ID tokens. So once you see tokens, you can already imagine that they are kind of tokenized, right? There's a POS tag, so part of speech, chunk tags, and a NER tag. So this is probably the one that we want to use, right? And we got quite a big amount of training samples, 14,000, which is quite adequate. So let us first, so we're gonna go to train, and we're gonna go to ID 0, and we're gonna get the tokens. So this is exactly how it looks like for the first sentence, right? EU rejects German call to boycott British lamb. And the next thing we can try is what are the associated tags, right? So we can do the same. NER, let's see, NER tags. Okay, great. And so we got some strange number, but probably this tree means some kind of tag, and a 0 probably means that there's no this data set did not annotate this as any entity, but I think we can always check the name, right? So we can do train the features tags, right? And it seems like we got some sequence like a list, and it defines some class label, and that is 0 is basically now, and 1 is beginning of a person, and 2 means anything that is a person, but it's not the first word of that person, right? Like John Carter, then John is B pure, and Carter is I per, right? Yeah, organization. So obviously this is organization, right? Because it's tree. We got location, and then we got miscellaneous. Okay, great. So I think this is gonna be very useful later on. So what I'm gonna do is there are features. Go to raw data sets, train, features, NER tags, right? So this is exactly this guy. And then I would say that label names, which maps the ID to the label, is nothing but NER features dot. So if this return this, then I can get feature dot, and then we can get the names, right? And that could probably be like a very nice okay, give me 1 second. This one should be names, right? Right. So now we convert a nice label names that we can always convert any ID to the label, right? Great. So that's it. I invite you to actually take a look at post tags and take a look, right? But in this tutorial, we're gonna work on only NER tags. Great. So I guess that's it. Now that we understand our data set, we can close this. So great. Now let's go to pre-processing. So once again, I feel like in this tutorial, pre-processing is probably the most challenging part, because you have to be familiar with your tasks and know how to actually pre-process them, right? Right. So firstly, we're gonna import some tokenizer, and we're gonna use auto tokenizer like abstract class. And then the checkpoint equal to we're gonna use bird base and is case sensitive, and tokenizer is equal to auto tokenizer from pre-train and from this checkpoint. All right. So we can always check whether we really have a tokenizer, right? So we can say deep learning is fun. Yep. Right. And yep. Okay. So obviously we see that we got input IDs and seems like it tokenized to something. And there's a token type IDs and attention mass, right? So yep. So let us try to understand what is this input IDs, right? So what we can do is tokenizer.decode. And what we're going to do is just copy this, right? And we can see that, okay, so this tokenizer basically attach your CRS and separator for the next sentence for us, right? Great. You may wonder, like, what is token type IDs and attention mass, right? So token type ID is basically like if you in certain tokenizer, it will basically categorize the type of tokens. And attention mass is basically saying that, hey, for any token padding, this will be 0. That means that you should not pay attention to those tokens, right? So those are meaning. Once we come across this, we will better understand what are those, right? Great. So we also I also want to introduce something called is fast, and usually it's set to true, right? So this is Huggingface built-in tokenizer that can basically perform very fast, right? Using some kind of parallel computations, right? So yeah, if it's a false, then make sure that you set it to true, right? Simply doing something like that. All right, and then now we can actually try with our data sets, right? How the tokenizer works. So firstly, we can say tokens equal to raw data sets 0 and tokens, and this is basically this. And now you may wonder, like, hey, Chucky, it's already tokenized, right? So why do we need to tokenize more, right? Well, we want to always enjoy the possibility that some tokens can be further tokenized into subwords, right? So that could be a possibility. Another possibility is not a possibility. You want to add a CLS and a separator at the end, right? So let's try to do this. So we can say inputs is equal to tokenizer tokens, and we have to tell the tokenizer that our input is actually already split by words, right? So that it can expect that it's split into words already, true, and we can now take a look at the inputs. So we can see that we got some input IDs, and later on we can decode that, and we got some attention mass. Everything is 1. So let us try to do this. So we can do input.tokens.tokens, right? And okay, great. Now so let us. So you can see that this is what the tokenizer gave us, right? Which is a CLS, and everything looks the same, but notice that lamp is chopped into two words, LA and too sharp and MB, right? So we can assume that LA is a very common subword. So that's why the tokenizer do that. So subword tokenization is a very powerful idea, right? So that's why we always welcome this and help in the case of out of vocabulary a lot, right? And what is this too sharp is basically just determine that this is something that connects to the previous word, right? So yep, it's not always in this format. Depends on the tokenizer. In this case, we're using bird tokenizer. So and this is how the bird do. Great. So now we can we of course we can take a look a little bit more. So we can do raw data sets, train 0 and NER tags. Right. So now we have this, but now we got a problem because once we tokenize, we got something like COS, and we also have two extra tokens for the word, right? So we no longer can use this NER tags because you can count they are not exactly equal, right? So we have to kind of map that. That would be probably the most challenging. I would not say challenging, it's only a few lines, but that would be probably something require a lot of thoughts. And of course, you don't have to actually worry. How do we know that something is split into two words, right? The tokenizer indeed already gave you something called word IDs. So once you punch this, it will already give you something that is very useful. That is, if it's none, it's basically that it's not a word that is originally in there. And this is basically 0, 1, 2, 3. But notice that it also helped you already to annotate that this two word indeed is actually come from the same word, right? And again, and switcher. So if we can use this word ID along with this, then we can actually rewrite our labels to actually match to this tokenized version, right? So let's do this. So the let's say that let's call this align labels with tokens. Labels. So the input is the labels, which is this one. Okay, and word IDs, right? And which is this one, right? So we expect that we got input, right? So firstly, we need to define new labels equal to a blank, and a current word is equal to none. All right. So what is the idea? Well, you start with the word ID, and if the current word is the same as the next word, then we have to do something. It means that they are basically the same word, right? So we have to do something. So let me just open the label names again, and you can see that if this is let's say this is a BOC, right? If this is the next word and it comes from BOC, then we have to make this as IOC, right? Because this is no longer a BOC because it's the next word, right? So we always need to kind of instead of the label as 3, which is +1, it becomes IOC, right? So that would be something we have to consider. Otherwise, in other case, if it's 0, then just attach this ID. If it's 1, then just attach this label, right? And if it's none, we attach some label that is that designate that this is actually a separator and COS, right? Great. So those are something we have to think about. So firstly, we're gonna for a word ID in word IDs. So we're gonna loop through this one, right? And the first case is that if word ID is not equal to current word, so that means that it's a new word. We are very sure that it's a new word, right? But by the way, we also have this case, right, in which this is gonna be the same as this one, right? Which we're gonna write in here. Word ID is none, right? Then new labels dot append minus 100. And you may wonder why minus 100. Minus 100 is basically a default index that Huggingface will ignore, right? Okay. So now we also have the next case, which that is this, which they are basically the same thing, right? So, but firstly, let's do the simple cases, right? In which the word ID is not equal to the current word, which is basically the previous word, right? So firstly, if not, then we now set the current word into word ID, all right? And then the label equal to minus 100 if word ID is none, right? So in this case, this will work when you see this, right? Because the previous word is 8, so this can fall into this case. Otherwise, we just set the labels to basically the labels of that word ID, and now we're going to say new labels dot append label. All right. Yep. I guess that's it. Lastly, label equal to labels word ID. So if they are basically this is 0, 1, 2, 3, 4, 5, and 7, right? So if they are odd number, then we always need to plus 1, right? Meaning that they so for example, if this is 7, right? And you can see that if this is something that is the odd number, especially 1, 3, 5, 7, then we have to move it to I, right? So that is basically the idea. Now what we're gonna do is if label mod 2 equal to 1, that means it's an odd number. Then we just set the label plus equal to 1. All right, and then we're gonna say that new labels dot append label. Yep. This is probably the only part that is difficult in this tutorial. Otherwise, the rest is quite obvious. Yep. All right. So hopefully I wrote everything correctly. So maybe I can put some comment. This is not obvious actually. If the label is VXX, we change it to IXX, right? And this is if the current token is the same, it is the same word as the previous token, right? Great. So so let's test this out, right? So labels equal to raw data sets, train 0 and NER tag, right? So that is our labels, and word IDs, inputs not word IDs. All right. Print labels. All right. Okay. We don't have to print labels. So now what we're gonna do is print a line label with tokens, and we're gonna send this together, right? Yep. And you can see that now everything is mapped nicely. Like none become minus 100. This one, this is basically put it all here, but you can see that 0 is double because they share the same word. But why is not plus 1? Because this is not a number, right? Great. So it seems like it works. So now what we're going to do is actually apply to our data set, right? So we're going to say that tokenize data sets, and we're going to use something called map, right? We're just going to, what does it mean? It means that for each of the row, please apply this function. So tokenize, okay, so we have to first write this function, right? So we're gonna imagine that we have this function called tokenize and align labels examples, all right? And tokenize inputs is basically tokenizer. And we can imagine that inside each of the row, there's something called tokens. And we're going to say truncation equal to true. And it's split into words is true. All right. Now, what we're going to do is get the labels of this sentence. Okay. And we also need to set the new labels. So for I labels and the rest, most of this is quite, once you understand this function, the rest is quite easy. So you enumerate all the labels, and word IDs is equal to tokenize inputs dot word IDs at the position I. And what we're going to do is we're going to say new labels dot append, and we're going to say align label with tokens, and we'll send in two things, right? Labels and word IDs. Yep. All right. Yeah, let me just make sure that's correct. Okay, great. Should be okay. Okay, great. I think it's correct. Now tokenize inputs labels is now equal to this new labels, right? And then what we can do is once we get this labels, we can just delete everything else. Return tokenize input. Great. So this is the each of the sample, right? We're gonna apply this function and then do all this mapping, and then we're gonna return this tokenized inputs. Great. So now what we're gonna do is we're gonna call this function. Let's run this, and we're gonna call this function, and we're gonna say batch equal to true. Well, you can do batch. Basically, it just send us a batch, not each of the row. And then we're going to say that once you do this, please remove the columns, every column, basically. We don't want this anymore, right? So we just say that everything, right? So once you do this, you only left with, I would say, what the tokenizer gave us. Basically, that's right. We will no longer have the tokens column, etc. NER tags is gone. Chunk tags, POS tags is all gone. We only have whatever we need, right? So I guess that this one would take maybe, I'm not sure. Hopefully it doesn't take too long. Let's try this. Yep. So it's actually very, very quick, even though our data sets is quite big, right? So yep, quite strong and quite quick. So now we can do tokenized data sets. And now we can see that we no longer have POS tag and NER tags and labels. I mean the NER tags, but we only have input IDs, token type IDs, attention mask, labels. So this is what we're gonna currently have, right? This is great. Why not we take some time to print this, right? So we can say For example, the tokenized data sets, train, 0, input IDs, right? So this is the input IDs. And of course, we can do to decoding, the tokenizer.decode, and we can actually decode this, right? And that is what we got. Definitely, we can take a look at the labels, right? And it seems like everything works very nicely. We can change to 1 and see how does it look like. It's quite a short sentence. Okay, great. Okay. So I think we got the pre-processing done. Like I said, for different tasks, there will be their own challenge. How do you pre-process them? So make sure that you understand the nature of the task that you work with. In this case, I can imagine that most of the token classification tasks will do something similar along the line like this, right? So once you learn one task, you usually can transfer your knowledge to similar types of tasks. All right, data loader. So from transformers, import data collator for token. Okay, so Huggingface already provided a lot of stuff for us, so we can just say our data collator is basically data collator, and just send in this one. Great. So you may wonder what is this? Well, it's just a function that helps you prepare your data right away, given your token answer. So it's very handy. Of course, you may say, why not? You want to write yourself? Yes, you're welcome to actually write yourself. Definitely, we can actually try. So we can say that tokenize data sets, train, and let's say we have input I for I in range 1, and we can print test, right? And you can see that we have this thing, and we can actually run the data collator. I should put 2, yeah, just so that it seems like this batch, right? So this is the first, and then this is the second. Now what we can do is we can actually see what the data collator give us. Test, right? So you can see that the data collator basically prepare everything very nicely. Input ID is stacked together. Token type ID is stacked together, and attention mask is stacked together, right? So basically, this is what the data collator help us already. Great. So before anything else, we just try to put it into data loader. Bring loader. Shuffle equal to true, and the late function is basically this function. Yep, and batch size equal to, yeah, let's say 8, right? And we're gonna duplicate this one more time. You can actually use the test 2. I'm just in this tutorial, I guess if I'm not wrong, I'm only doing for validation, and you don't need to shuffle for validation because you just test everything. You can set the batch size to everything, but I'm just gonna keep it like this because I'm using MacBook. I'm not sure it can handle so much information. Yeah. Okay, great. So we got this loader, and that probably is it for the data loader. For the model, it's just a couple of lines. So firstly, we have to define the vocabs. So we just say string I, label for I, label, and enumerate label names. And label to ID is basically so we could just creating a mapping for KB and ID dot items. Yep. Let me see. Okay, we need a bracket. All right, and then what we need is from transformers, we're gonna use abstract class auto model for token class. Okay, for model for token classification. Yep. All right. And then what we're gonna do is model equal to auto model from retrain checkpoint ID2 label equal to ID2 label and label 2. Yep. So yeah, essentially we are actually we did not train from scratch. We use this checkpoint what did the bird actually already train, and then we just continue train fine tune that model using our data sets, right? So this is a very basic idea. All right. And I think now this is probably the last step we have to write, and the rest is the code is very simple. So before you do this matrix, I have to say that this is optional. You can do this pips install sequence eval, which is mostly for sentence. If you want to some sentence, right? But if you don't want to, you can write from scratch always. So we can, for example, let us first import and show you how does this matrix work. So the evaluate load a sequence eval. So this evaluate has a lot of library. I mean, a lot of matrix. So one of them is sequence eval, in which it compares two sentences and give us a lot of numbers. So labels equal to raw datasets, train 0, and NER tags, right? And we can actually now I'm just trying to demonstrate how this works, right? So actually what we can do is just create some fake by perturbing this guy. Wait a minute. Let us get them labels. Because this matrix, this sequence eval, they expect string. They did not expect number actually. So that is a little bit strange, but anyway, yep, it works fine too. Okay, great. So now we got a list of string. Now we're just gonna let's say fake. Let's say labels 2, and we're just gonna perturb it. Labels dot copy, and we're gonna say that labels 2, the second guy, equal to let's say b orc. All right, labels 2. Okay, so the difference is here, right? And then what we can do is now use this matrix.compute and give it to be predictions equal to basically labels 2. And you notice that I'm actually putting a list, right? So they actually expect a list and references equal to labels, and you can enter and you can see them. Based on this metric, we can get a lot of numbers like precision, recall, F1, etc. And it's not only for, it can be for the miscellaneous tag, the org tag, right? So this sequence eval is perfect for token classification. Great. The rest of them is quite straightforward. I'm running an optimizer, and then the accelerator is basically, you, by the way, you can actually write your own code from scratch, but whenever possible you should use accelerator because it's much faster than your typical one. There's also something like you should also check something like DP, in which it like data parallel, and there are so many variants that actually teach you how do you utilize your GPU, multiple GPUs, right, to accelerate your training, right? But of course, if you're beginners, you may want to just use accelerator and try and enjoy the benefits of parallelism. But once you get in your thesis zone, then you may want to actually write your long dose of parallel functions. Yep. But anyway, this accelerator, you just need to put in the model optimizer and your data sets, and that's it. And then we also have something called learning rate scheduler. sklearn also have this, but basically we just say that it's a linear, slowly going down, right? If I'm not wrong, right? And the number of step in which it go down depends on, it's basically so number of steps is basically the total steps, right, that we multiply, right? So based on that, it will create a scheduler and slowly go down based on these steps. Repository, so you can so this is entirely optional, but if I'm not wrong, if you want to use accelerate, you have to push your model to Huggingface. So you just log in, get the token from Huggingface, create a token. So once you punch this in, they will ask for your token, and then you can define whatever name, like Chucky Bird, right? And then it will just create a repository. It's just basically like a GitHub repository, but this is called Huggingface repository, and the name is this, and this is basically my username, right? And then what I do is basically the output directory is this, all right? If I'm not wrong, that is I also have this, right, in which the models is all here, right? Yep. And then the training starts here, and I wrote up a post-process functions. If you don't understand this is basically trying to convert them into the form in which the matrix needs, right? So it needs those label names, etc. So there's a lot of messy code to process the answer. But anyway, for the training is very obvious. The only difference is the accelerator dot backward. And you can imagine that usually we input the whole thing, just the input, right? In here we just input the whole batch, right? In which the batches has input ID, attention mass, and you don't have to worry because the Huggingface expect those input. And double star here just try to say that this is a keyword arguments input. So it's basically a dictionary, right? When you evaluate, make sure you don't use gradient, you argmax, you do some padding to make sure everything is padded to its maximum length. You have together because the reason why you need to use the accelerator is all you're not in different GPU, right? So you have to do this across all the GPU, and then you have to let the accelerator do this for you. And finally, you just add these numbers to the matrix and let the matrix compute everything. And actually, I have the number, but it's not right here. I actually do already one time. Let me see whether I have those numbers. But by the way, it took my MacBook actually can do this, and it take me around 15 minutes. So if you're using MacBook, you can also try. But anyway, let's assume that it's done. And what if you want to now actually use this model to classify your own text, right? So similarly, you just load your model, create a pipeline, and just input anything, right? And you can see that it's doing quite well. It can know that I use this person, myself as a person, AIT is a location. Of course, it does not know that soccer is sports. And you may wonder why. That's simply because our data set never teach that entity type, right? So yep. So but anyway, enjoy it, and I guess here you already you can learn a lot about token classification. Yep. Thank you very much, and see you in next tutorial. Bye bye.